As you know that in last lecture we were discussing about how we can convert our conceptual schema, which was our entity relationship diagram, ERD, entity relation diagram, how we can convert it to our logical schema. And we saw that we can convert it through several steps, and these steps were 7. And we saw we can convert our regular entities, which were represented by rectangles in our ERD, to directly our relations or the tables. And we saw that in our company conceptual schema, we had 3 regular entities: employee, department, and project, and we converted them into our relations or tables. Then we saw how we can map weak entities, and we saw that we have a weak entity dependent. We can convert it to our relation, but for all weak entities we copy the primary key of the parent. Here for the dependent, the parent is employee, so we copy the primary key of employee, which is SSN, into the relation dependent. So this is our dependent relation or dependent table, and we copied SSN, which was from the employee table. We copied it here, and then this primary key, with here it will become a foreign key. This foreign key together with another or more than one other attributes, that will become a primary key for dependent table. So you see the primary key of the dependent table is composite, that comprises of ESSN and dependent name. Similarly, we learned that whenever we have a binary relationship, yani relationship between 2 entities, we should find one of them as parent and second one as child, and we always add the primary key of parent into child relation, and there it becomes a foreign key. This is the general principle that we have learned, and it will be applied everywhere. Then we saw that our derived attributes, we never store that in our database, so we never map them to anything. We will always be calculating derived attributes at runtime in our Oracle, in our queries, in our reports, wherever we have some derived attributes, we will be calculating it at runtime. Then we started learning at the binary relationship of different types, and we saw how do we map one-to-one relationship. We saw 3 cases. In first case, when both sides were mandatory. In second case, when one side was mandatory and second was optional. In third case, we saw when both of the sides are optional. And we also noticed that we should concentrate on the cardinality, which is the maximum value, because looking at the minimum value in one-to-one relationship will not help us. So we were looking at the maximum value. Then we saw that how do we identify the mandatory sites and optional sites, and we saw that wherever we have 1 in the cardinality or the minimum value, we will consider it mandatory. So here we have 1, it indicates mandatory. We also have 1, it also indicates mandatory. So in case of mandatory, we make only 1 table which carries all the attributes of first entity as well as the second entity. And then we saw the example. In second case, we saw that one side is mandatory, it's 1 here, indicates mandatory. Other side, it's 0 here, so it indicates optional side. In case we have 1 mandatory and 1 optional, it can be left or right, doesn't matter. We will create 2 tables. One table for left hand side entity. Here in this example it is staff, and another table for car, and they will have their own attributes. And in this case, to show the relationship between the two entities, we will add the primary key of the mandatory side into the optional side. Here the mandatory side is staff, the primary key of the staff is staff number, so we will add staff number into the optional side. The optional side is car, optional entity is car, so we will add the primary key, which is staff number, into the relation car. Here it also becomes staff number. Now you know that if an attribute in one table is the primary key, it has its reference into another table, so we make it a foreign key here. And then we saw the third case in which both of the sides were optional. 0 indicates optional side, 0 indicates optional side. We create two tables when both of the sides are optional. And of course, once again, to show the relationship, we add the primary key of, here we have to find parent and child, and we can see that from staff and car, the parent can be staff, not the car. So we added the primary key of staff into relation car. Here it becomes the foreign key because it has its reference from its parent table. Okay, so from here onwards, we are going to start our today's lecture. Today we are beginning with looking at one-to-one recursive relationship. We have been studying one-to-one relationship, and the last case we are going to study one-to-one recursive relationship. You know, recursive means if one entity has its relation with itself. For example, we had an entity staff and it has a recursive relationship with itself. Now once again, there can be three possible options for recursive relationship in one-to-one, and the cases are the same when both sides are mandatory, and as usual, as we saw in the normal one-to-one relationship, that when both sides are mandatory, we keep one table or one relation. And again, to show the relationship, we copy the primary key once again into the same table. I will show you how do we do that. Second case, in second case, we have both sides optional. If we have both sides optional, then we create two relations. Once again, in two relations, also in this case, we add the primary key of the parent into the child. And here in recursive relationship, we know that there is only one relation, there is only one table. So we copy the primary key once again into the same table. You will see, you will understand it with the help of example. So both sides mandatory, both sides optional, we saw. Question is, what happens when one side is optional? So if one side is optional, you can consider first case in which you make single relation, or you can consider second case in which you make two relation. So it's now choice is yours. In case when one side is optional, you either choose the first where you make single relation, or you can choose second where you make two relations. Now in this case, choice is yours. Let's understand it with the help of example. So in our company database, we had a relation, we had an entity staff identified by a staff ID, staff name, and its department. And we saw that some of the staff members, they supervise other staff members. Okay, so for each of the staff member, he may supervise others or not. So the staff member may be a supervisor. If he is a supervisor, maximum he can be the one. So if he is the supervisor, he maximum he can supervise, that he can be the supervisor of one department. Okay, so each staff member may be a supervisor, If he is a supervisor, he supervises one department, or he may not supervise any department. Okay, you see here, this is 0 means optional side, this is 1 means mandatory side. So I am reminding you here again that we look at the minimum value, and the first value is the minimum. Here this is the minimum. So this 0 indicates that this is optional side, and this 1 indicates this is mandatory side. So we have one optional side, one mandatory. One optional, one mandatory. What we can do, we can either make single relation, because we have choice now, either to make a single relation or two relation. So we will study both of them. We will study both of them. In case we make one relation, it's here. Let me copy the same way that we have been doing before, so that you can easily watch it. Okay, so it's one relation, and you can make two relations also. So this shows this second relation. Okay, so what we can do, we can make the first relation one relation, or we can make two relations. If we make one relation, of course we can keep its name as a staff, and the parameters were, or the attributes were, ID, name, and department. So you see here ID, you see here department, and you see here name as well. One moment, send it to back so that I can type. Yes, now it's fine. Again, send it back. Now I can type ID, name, and department. And you saw that we copy the primary key, and the primary key here is the ID. So we copy ID once again here, and this copy is to show the relationship, and the relationship is supervise. And so one staff member, he can be the supervisor of other staff members. So it also means that each staff member has a supervisor. So we rename this ID as supervisor ID. This is example where you make one relation. In second example, you can make two relations. So one relation name is staff, and second relation name, you should try to utilize this relation supervise. So we give it a name as supervisor or supervision. So in supervision, what is there? Of course, we have to copy the primary key, which is ID. So staff ID, this is the ID, and to show the relationship, we copy it again as supervisor ID. Like here, you had ID and supervisor ID. So again, here you had ID or supervisor ID. You can call it staff ID, you can call it ID, etc. The name doesn't matter. Next step, we so far in last several slides, we saw one-to-one relationship. In next few slides, we are going to see one-to-star relationship. The methodology or recipe for one-to-one relationship is different, and methodology and recipe for one-to-star is different. Okay, so in case of one-to-star, what will you do? First of all, you should try to find parent and child. Which side is parent and which side is child? Let me show you here. So you see here binary relationship between branch and staff, and you see the participation. The participation, yani the minimum value, it's 1 here. It means it's 1 here, and moment. Okay, in one-to-star, we are not looking at minimum value, we are looking at maximum value. This you should remember, that in one-to-one relationship, we were looking at minimum values. In one-to-star relationship, we are looking at maximum value. Essentially, don't worry, you will come to know that side where there is 1, that will be the parent, and the side where there is a star, that will be your child side. Okay, so once again, you remember, whenever we have parent and child, we always add the primary key of parent into child. Essential thing we should remember that in 1 to star relationship, we make 2 tables. Once again, let's have a look with the help of an example. This is branch entity, this is staff entity, and they have a relationship 1 to star. In 1 to star, the first step is we find parent and child. The side on which there is a star, that is child, and the other side where there is 1, that is called parent. So this is parent, branch is parent, staff is child. We will make 2 tables, one for the branch, one for the staff, and we will copy the primary key of the parent into child. What is the primary key of parent? Branch number. We copy branch number into child table, which is staff, and of course here it becomes a foreign key. Okay, what about when 1 to star is a recursive relationship? What happens? Again, the sense is the same, the concept is the same, that you can, in 1 to star, you can make 1 table or you can make 2 table. Best is save your time and effort, make it 1 table. And 1 table is with the name of staff, we make it staff. And you remember that in 1 to star relationship, we identify the parent and child. Since it's recursive, so the same table is parent and same table is child, and we will copy the primary key of the parent again into the same table. What was the primary key here? Staff number. We will copy it again here, now with the name of the relationship. What is the relationship name? Supervision or supervisor and supervisee. So you can call it supervisor staff number. Staff number will be copied it here again with another name, because we cannot keep the 2 column names same. This is not allowed. 1 column name is staff number. We are copying it here, so we should keep a different name, and we keep it here staff supervisor staff number. Now, I think this is the last case, that is star to star relationship. When there is star to star relationship, what do we do there? In star to star relationship, we create 3 relations. So 2 relations for 2 entities, and the third relation representing their relationship. Okay, so let's see with the help of an example. This is entity video, this is entity actor, and we see here the relationship is star to star, because in star to star or 1 to star we see the maximum values. So here it is star to star. Let me draw some arrows for you so that you can remember. This is star, and star to star relationship. Now you see here star to star. Okay, so it means now we should create 3 relations. We should create 3 tables. 1 table with the video, so this is the video. Another table for the actor, this is the actor. We will create a 3rd table to show the relationship, and here the relationship plays a role in a video. An actor plays a role in a video. So the third table you can call it role. Okay, essentially in role there is 1 attribute here, that is what role is he playing. So yani his character or his role, you can call it character or role. So this is here. Then the important thing is you should add the primary keys of both of the tables, video as well as actor. into the third table, because third table is the child table. These both tables are the parent tables. As always, the primary key of the parent is copied into child. What is the primary key of video table? Its catalog number. That is copied here, catalog number. If the attribute goes into another table, you can keep the same name. But if the attribute is copied into the same table, then the two column names cannot be same. So we must change the name. However, since video is another table, role is another table, so you can keep the same name, catalog number from here into the other table, which is role. The same name can be here. Okay, we copied the primary key from video table here into role table. We should also copy the primary key from the second relation, which is the second parent. Its primary key is actor number. This should be copied here into the third table. So once again, the summary is in star to star relationship, you create three tables or three relations. You can now realize that in such a case, it's very important to make a correct ERD so that you can exactly map their relations, their entity types, and their relationship types, and their cardinality and the participation into the next tables. Okay, next is how do we map our complex relationship? So any relationship which represents more than two entities, that is complex. In this case, it is three entities, and so we will call it complex relationship. So in all complex relationship, there will always be created one table for the relationship. How many entities do we have here? Three. Three entities are here, and so three tables will be created for them. One table for branch, one table for staff, and one for member. And in complex relationship, we will create another table to represent the relationship. So for this example, one table will be created for branch, one for staff, one for member. See here, one for branch, one for staff, one for member. And a fourth table will be created to show the relationship. What is the relationship? Registers. We can call it registration. So fourth table, registration. As always, we know that the relationship is always considered as child table. So whenever we have a child, we copy the primary key of the parents. How many parents do we have here? Three parents. So we will copy the primary key of branch into registration, member into registration, and of staff into registration. See here, the primary key of the branch is branch number. We copy here branch number into registration table. Primary key of member table is member number. So we copy the member number into registration table. Similarly, the primary key of the staff, which is staff number, is also copied here. Now, whenever we copy the primary key into other tables, they become the part of the primary key in that table. So the registration table will have a primary key consisting of branch number, member number, staff number. So together they will make a primary key. Or you can also, if you need, you can join any other column from the child table to make the primary key. Once again, I'm repeating that if a key is copied into any other table, so it means this branch number has its reference back from the branch table. That means it is a foreign key here. We will make a foreign key here. And member number, it has a reference back to member table, so we will make it a foreign key here. Staff number also has its reference back in staff table. We will make a foreign key here. Okay, I think this is the last or the second last thing for the mapping. Multi-valued attributes. Any attribute, if it has more than one values, the possibility it has more than one possibility of more than one values, like your phone numbers. Some of the people, they have more than one phone numbers. So for those multi-valued attributes, a separate new table is created. For each multi-valued attribute, a separate table is created. For example, look at this entity, branch. It has attributes branch number, it has telephone, and there is a possibility to have one telephone number or two telephone number or three. So starting from one, minimum one telephone number, maximum three telephone number. It means this is a multi-valued attribute. For all multi-valued attributes, for each of them, we will create one table. Here we have one multi-valued attribute, telephone number. We will create a separate table for telephone number. Of course, branch will be converted to one table, and this multi-valued attribute will be converted to one table. Now, you see here that telephone number, it was a part of branch table. So definitely there is a relationship, and in this relationship, branch number is the parent, telephone number is the child. So we will add the primary key of the branch into the child table, which is telephone, to show their relationship. Of course, it will become, as usual, as we know, it will become a foreign key here. Okay guys, this is an exercise for you to practice at your home. So you see here, mashallah, several types of relationship, including these are the entities: manager, telephone, branch, staff, registration, client, lease, viewing, property for rent, advertising, newspaper, and all that. So, and then for each of the relationships, you have the cardinality and the participation here. So what you should do is you should look back into the slides and see how I taught you, and then considering all those things, you should convert them into the tables. You will convert. So this is the ERD for company database. From this ERD, you should make the logical schema, just like I taught you in this whole chapter, how each entity and how each type of the relationship will be converted into the tables. That you should do now, mashallah, at your home and practice it and see what tables do you identify, and then ask me if you have any problem. Okay guys, once again, a question. If I give you a question like this in an exam, that this is the ERD, converted, this is the conceptual schema, converted into logical schema, so you should make a table like this. Inshallah, will you be able to do that in your exam? How many phases of database design are there, guys? How many phases of database design are there? 3. Yes, Osama, thank you. We have 3 phases. Which 3 phases? The first phase is conceptual, mashallah. Second phase is logical. Third phase is physical. Yes, mashallah, Ibrahim, thank you. Conceptual, logical, and physical. We already saw in chapter number 3 what is conceptual design or conceptual schema, and we saw that we represented it with an ERD. In second phase, we made our logical design, where we converted our ERD into logical design. This whole chapter, this is sequence number 5. This whole chapter, which is actually your chapter number 9 in the book, it focuses on conversion of ERD into logical design. Now in logical design, we know which tables we need to create into database in Yani Oracle. In our case, we are using Oracle as an DBMS. So we are proceeding now towards the third design, Yani creation of our tables into DBMS Oracle and doing other things. To work with DBMS Oracle, we need to know SQL, which is a structured query language. So now we are going to start our SQL in class. Alhamdulillah, we have already started it in our lab. So we are quickly going to do some things, and inshallah now for some of the lectures we will be doing SQL in our class as well as in our lab. So we will be covering, because it's mashallah a good amount of SQL, a good number of queries, or the um, good hands-on experience inshallah we want to have for from several of the examples that we will do inshallah in our class.